Now let me tell you something, child. A man who stops learning is like a river that done dried up. Ain't nothing flowing, ain't nothing growing. This world don't sit still for nobody. It turn and it twist. And if you ain't moving with it, you get left setting in the dust, wondering where everybody else done gone.
Hello, and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett, and today we're going to use our good friend Nmap to discover the differences between a drop in a firewall rule and a reject, and also get to see the reasons why this is really important for you as a system administrator. So come on, let's jump onto our system and start understanding the differences between drop and reject. And look at this, my glorious Pixel Playground. A Pixel Playground where we have two libvirt virtual machines running. I'm on my Ubuntu system, but we have then two Rocky 9 systems running as VMs. Using Verge Net DHCP leases and the network they are connected to, I can easily then see the IP addresses that I need to work with. And these are going to be our firewall targets. We want to be taking a look at the differences between the drop command and the reject command when we set up our firewall rules. So working on my Rocky 9 system, this is the cloud system, we can see at the moment the target, and this is the rule that we apply if we don't match any of the existing rules within the zone, is default. Now, this isn't very descriptive because default is set on a per zone basis, so we don't really know what it's going to be. Of course, we get used to it, and I know then that this will be a reject. But this is my first firewall investigated, and let's move across to my second Rocky 9 system, and we can see this as a simple prompt of just Rocky. We can run exactly the same command, and we're going to get exactly the same result coming back as they are configured in the same way. So we're working with our public zone. The default target is set, and we're only allowing Cockpit DHCP v6 client and SSH through. So everything else is going to match the default target or rule. And as I say, this is going to be a reject, so we can investigate the behavior. At this stage then, it might be a good idea to return to my Ubuntu host, and we can look at our good friend, our very good friend, Nmap, our network mapper. We can look for port 80. Now, we know port 80 is not allowed through the firewall, but we can ask Nmap for a reason. But let's ask in a verbose manner, and then we can go through and put in our IP addresses. Usually they're dotted decimal format, so let's make sure we put dots in between them and not commas. So 192.168.122.212 and 192.168, and then we can put in 122 and then .141. So the two hosts, and we can see this came back really quickly, 0.02 seconds. Both of our hosts are down, but we've received a host unreachable message. So this means that the firewall actually sent out an ICMP message, meaning that our host, our firewall host, have to send messages back to each of these requests. But also, we're getting it back really quickly so the client can see that, oh, okay, we are down. Let's move on to something else. We can show you this again using netcat, sending 0 bytes, having a verbose output, and we can see then, I'm just connecting to one host here, but we get our client back straight away. Now, this is really important for our hacker because we're not slowing them down. They can then proceed to the next port or the next host. But also the whole idea that we're sending out ICMP messages, which is just totally unnecessary. We're going to really be able to see the difference, though, and why we still might want reject when we go through and specify the drop. So I'm going to explicitly set this. So even though we are rejecting at the moment, we are going to set it. It's always better explicit rather than implicit. I like the idea of that rule. So I'm going to set my target. We can use tab completion on this, and I can see the available targets. So default will be defined within the zone, but I'm going to change it through to reject. When I go through and set it, I have to work within the backend, so I have to work with permanent, but we can make sure that this is active by reloading. And now when I go through and do a list all, instead of seeing the target default, I see reject. But notice that reject is then encapsulated inside of our percentages, which means that we are rejecting with an ICMP message. However, from these simple rules, I can't control the ICMP message. We would have to do that through raw rules. Now moving across onto my Rocky system. Again, the same thing working in permanent. And then our set target. We're setting this to drop. We can go through and reload it. Remember, we want one on drop and one on reject so we can compare. We notice the target is dropped. There is no ICMP messages. So that is really good. Well, we're not sending out messages. Moving back now so we can compare when we look at our host. It's taking a little bit longer when we run our Nmap. And when we look, it took 0.02 seconds before. Now it took 1.22 seconds. But look at the reasons. 212, which was a reject, was host unreachable. Whereas you can see on 141, which was a drop, there was no response. So we don't have anything coming back. We haven't sent anything back. And we had to wait for a timeout. So we're slowing our client down. We'll really start to see this when we go back to our netcat command. If I go back to the 212, which was a reject, we get our client back straight away. So we get feedback. Whereas if I go through and take a look at the 141 system, but there's going to be no packet sent back. So drop is literally just ignoring the packet. So this means then we have to wait for the client timeout before we get control, or we do a control C. But additionally, we're not sending any packets back to the system. And in a massive attack, all of those ICMP packets that we're sending unnecessarily is an overhead as well. So drop is our secure method, but we don't get the immediate feedback if we're trying to debug issues.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.